And now it's time for 1.7. I need you guys to settle down a little bit though, because you're a little excited today. Okay. So, objectives for 1.7. Use interval notation. Find intersections and unions of intervals. Solve linear inequalities. Recognize inequalities with no solutions or all real numbers as solutions. Solve compound inequalities and solve absolute value inequalities. We alluded to this a little bit yesterday, and we'll really talk about that today. Okay? But let's start at the beginning. Use interval notation. Ready? We talked about interval notation in Algebra 2 because I didn't know where you guys were going as far as what your next math class was, so I wanted you to know interval and inequality notation. So what you're familiar with is something that looks like this. X is greater than 12. That's our inequality notation, right? So in order to write this in interval notation, we would have to say from 12 to infinity. Now, why is it a parenthesis on the 12? Because it's just greater than, right? Not greater than or equal, just greater than. So 12 is not included as part of our answer. So we use a parenthesis to not include it as part of our answer in interval notation. I also want you to know what the graph looks like. Okay, so here's 0, here's 12. So we could do two different things actually. And I don't know if we talked about this with you guys, so this may be something new. If it is, yay, something new. And if not, you're seeing it again and you're remembering. Okay, what could we put at 12? An open circle, right? It's an open circle because we are not including 12. But the other thing that we could put at 12 is a parenthesis, because that's what's on the 12, right? So we could put a 12 and going that way because it's greater than 12. Okay, so it could be an open circle like that, or it could be a parenthesis. Either one. Okay. So same kind of thing. What if it was x is greater than or equal to 12? What's the difference? Now 12 is part of the answer, right? So it is a bracket on 12. Going to infinity. And the graph? Correct. So either a closed circle or a bracket. Shading to the right again because it's greater than. Okay. What did I forget? Do you see it? Yeah, parentheses on the... when do we put a bracket on a parenthesis? Excuse me. When do we put a bracket around infinity? Never. Yeah. Why do we never use a bracket around infinity? That would imply we know where the end of infinity is, right? Like all infinity is included and we don't know anything about that. Okay? So what about this? 2 is less than or equal to x is less than 4. What if it's like a inequality like that? What's the interval notation going to look like? Very good. 2, 4. Bracket by the 2. Perfect. So again, bracket on the 2, parenthesis on the 4, and this time it's between because it's greater than 2 and less than 4. We could put a closed circle on 2 and an open circle on 4 as well, couldn't we? And then it would just be a line in between the two. Negative 2 is less than x is less than or equal to 8. Bracket. Okay. I'm going to put the number line underneath because I kind of got in the way right there. So negative 2 to 8. So again, exactly what we use for interval notation is what we can put on the number line. Like that, right? Or open circle here, closed circle here. Any questions? Pretty good? All right. Awesome. Intersections and unions of intervals. Intersections and unions of intervals are not something you have seen before. You've seen intervals, but intersections and unions are something new for you. Okay? So let me give you an example of what I mean. 1 to 4. 1 and 4 are not included. 2 to 8, and both 2 and 8 are included. Okay? This symbol right here, this upside down U, stands for intersection. Okay? And it's where they both are. So I'm going to show you what I mean by drawing a graph. Is that okay? Okay. So the graph of the first one looks like this. Here's 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay? So from 1 to 4 would look like this. 1, 2, 3, 4 to 4. Right? Does that make sense? And the second one, here's 0, 1, 2, 3, 4, 5, 6, 7, 8. Goes from 2 to 8. Like that, right? So where are they both? So like right here, right? That's where they both are. So the graph of both of them together then would be, it would start at 2, right? It started 2. Now is 4 included? Well, it's included on this one, but not on this one, so I can't include it here. So this is like both of them. Now how would I write this answer in interval notation? 4, right? Okay. So that's intersection of intervals. Okay. Now let's talk about unions of intervals. And it looks like this. I'll do it in a different color because that's more fun. 1 to 4, union 2 to 8. So this one means union. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. Like that, right? So this one we said both, right? It's where they both lie, but this is more like all. It covers everything. So where does this one start? Starts at 1? Is 1 included? No. And where does it go to? 8. Is 8 included? Okay. So we said all, and it's really another way to think about it is one or the other or both. This one is the only place where it is where they both are. Right here and right here, right? This place, this place. That's where the answer can live. This one's like, how far does the lowest one go? And then how far the highest one go? And then it's everything that's there. Does that make sense? And so how would I write the answer here? Okay? Does that make sense? Any questions about that? So that's intersections and unions of intervals. Okay? Now we get to do fun stuff like linear inequalities. Ooh. This is not difficult because of the fact that we've been doing it for a while now. Okay? So let me give you a couple examples just so we can talk about it. Okay? 3 minus 2x is less than or equal to 11. Negative 2x is less than or equal to 8. Divide both sides by negative 2. X. For sure. Greater than or equal to negative 4. Now, why did this change? I divided by a negative. When I divide by a negative number, I have to change this sign. I have to flip it around. Okay? Now, I walked you through that in Algebra 2. Do I need to walk you through again why that's true? No? You got it? Okay, good. And typically, we don't just write this. We also graph it. So here's negative 4 and here's 0. So it's everything greater than or equal to negative 4. So bracket, greater than or equal to that way. Yes? X plus 5 is less than x minus 4. So if I subtract x from both sides, I get 5 is less than negative 4. You were starting to say the right words a minute ago. Why is it no solution? When is 5 less than negative 4? Never. Okay? So one of the things that it asks you to do is to recognize inequalities with no solution or all real numbers as your solutions. Okay? We just found one that has no real solution because when we simplify down to what we know we're supposed to do, we're supposed to get the x's together, we're supposed to get the constants together. When I subtracted x from both sides, it eliminated an x, the x at all, and I got this sentence. 5 is less than negative 4. That's not true. It will never be true. No value for x that if I put in here will ever make this statement true. Okay? What about this one? Because when I subtract x from both sides, I get negative 4 is less than 5. That's always true, so what do I mean by all real numbers, though? What am I solving for when I solve an inequality like this? I'm solving for x, right? So what do I mean by all real numbers? Literally any value of x that I put into this inequality, make it true, right? That's exactly right, okay? So 10, like 10 should work, right? So 10 minus 4, 6. 10 plus 5, 15. Is 6 less than 15? Literally any number that I choose for x will make this statement true. Okay? How do you feel about that? So the next thing on the list is solving compound inequalities. Again, we kind of looked at these in Algebra 2, but not really closely because they're really, solving inequalities isn't our teaks, but compound inequalities is, we just kind of went there because we could. Okay? So there's two different ways that compound inequalities can look, first of all. They could look like this. Negative 3 is less than 2x plus 1, and 2x plus 1 is less than or equal to 3. If it looks like this, how do I go about solving this? I just do one at a time, don't I? Just one at a time, okay? So I ignore this one over here, and I just look at this one. Minus 1 minus 1. Negative 4 is less than 2x. So divide both sides by 2. X equals, not equals, weirdo. X is greater than negative 2. Or negative 2 is less than x, right? Either way. And now I go to the other side. Minus 1 minus 1. 2x is less than 2. Divide both sides by 2. X is less than 1. But I have to remember this word from right up here, and, so that when I go to graph it, I do, on the same number line, don't I? Okay, I do graph both of them. I've got negative 2 here, and I've got 1 here. It's everything greater than negative 2, so parenthesis on the negative 2, and then everything less than 1, and everything less than 1. Ah, thank you. I did miss that, didn't I? Thank you very much. So what should this be? A bracket then. Good catch. Appreciate that. So then that should be everything in between. Okay? But see, there's another way this kind of problem can look. Okay? The other way it can look is like this. I can actually have two inequality signs in my problem. So when I go to subtract 1 from both sides, quote unquote, both sides, that's what we've always said, right? Because we've only ever had 2 sides. How many, sides do I have now? 3. I have this one, and this one, and this one. So if I subtract 1, I just need to subtract it from all the sides, right? From everything. So minus 1 here and minus 1 here. So I get negative 4 is less than 2x is less than or equal to 2. Everything, right? Divide everything by 2. Here, here, and here. So negative 2 is less than x is less than or equal to 1. Now the only difference between this answer and this answer is just really how it's written. Because when I go to graph this, it's going to be the exact same. Except I'm going to do it right this time, because that's a bracket, right? Not mess up, okay? This is just written this way, and this is written with the and, 2 separate problems. Okay? Any questions about that? Last thing we need to talk about is absolute value inequalities. And this is where we talked yesterday in our notes in 1.6, how it makes a difference how we think when we're dealing with absolute value. Okay? So first of all, let's start with the problem. I'll give you a problem like this. Absolute value, negative 2 times the absolute value of 3x plus 5 plus 7 is greater than or equal to negative 13. Okay? So just like yesterday, the first thing I want to do is isolate my absolute value. Okay? Isolate my absolute value. Okay? So I do that by, what do I want to do first? Good. So negative 2 times the absolute value of 3x plus 5 is greater than or equal to negative 20. Good. And then, correct. Is an alarm bell going off in your head? It should, right? Why should an alarm bell going off in your head? Correct. We do have to flip our inequality sign right here so that this is less than or equal to 10. So yesterday it was fine for us to say what's inside equals 10 and what's inside equals negative 10, right? But today is where it really makes a difference. Today it's the thing that's inside that could be either positive or negative. And that really makes a difference when you have an inequality sign. So we want to break this into 2 parts just like we did before. Hold on a second. Solve. And then 2 parts. Right? So we isolate it. Well, I guess after we isolate it, then we have 2 parts and then we solve it. Sorry. Here's my 2 parts. My first part is 3x plus 5 is less than or equal to 10. That's if what was inside is positive. Okay? Then I have what if what's inside is negative. Looks like that, right? I've got my two parts. So now we solve each part separately. So subtract 5. 3x is less than or equal to 5. Divide both sides by 3. X is less than or equal to 5/3. Then I have the other side. How do you want to go about this? Remember, there was two ways. We could either distribute the negative through to begin with, or we could divide the negative away to begin with. We're going to have to divide it away anyways, right? So you want to do it first. Alarm bells. Okay. This one right here. So greater than or equal to negative 10. So now subtract 5 from both sides. 3x is greater than or equal to negative 15. So x is greater than or equal to negative 5. So this is where we had to decide, is this an and statement or is this an or statement? And statements look like this, like the one we just did, where when we shade, it's like toward each other, right? What's or statements? When there's two parts, when they're shading, when they're the arrows are going away from each other, right? So some people like to decide first. I just like to graph it and see what happens. Okay? So here's my graph. Here's my negative 5. Here's my 5/3. It's everything less than or equal to 5/3. So I know on my 5/3 I've got a bracket, right? And it's going that way. This is greater than or equal to negative 5. So again, it's a bracket, but it's greater than, so it's going that way. So now tell me, is it an and or is it an or? Because it's going toward each other, right? So it's and both of these. Remember, if it's an or, you can't say any random number. It has to be in one section or the other, but it won't ever live in both. Okay? So the other way we can actually write this answer is to make it look a little bit more like this and say negative 5 is less than or equal to x is less than or equal to 5/3. You can't write or statements like this. Or statements have to be this or this. You can't combine them like this. It doesn't make sense. Okay? Can we do one more of those? Absolute value inequalities? Okay. 5 minus 2x is greater than 7. Whoa, sorry. So first isolate. Okay, done. Now two parts. So 5 minus 2x is greater than 7. And negative 5 minus 2x is greater than 7. Okay? So subtract 5 from both sides. Negative 2x is greater than 2. So divide both sides by negative 2. And x, oh, good catch. Alarm bells. You heard the alarm bells, didn't you? What about this one? I'm sorry? Because I just forgot the negative sign. Thank you. No, I think I even said negative 1 and then just wrote regular 1. And even if I didn't, I'm sorry, I messed up. Please forgive me. But very good catch. Okay? Now, why would this be a situation that I might want to distribute? It's already negative, right? So if I distribute it, then it'll be positive, so when I do my dividing. Otherwise, when I divide first, I'll have to flip the sign, and when I divide again, I'll have to flip the sign again, right? Okay? So what if we distribute it here and here? Then I get negative 5 plus 2x is greater than 7. So when I add 5 to both sides, I get 2x is greater than 12. And when I divide both sides by 2, I get x is greater than 10. Yeah, I think I'm just hungry. I'm sorry. Let's pretend I meant 6 the whole time. Ignore that. That's a frowny face. So I've got my -1 and my 6. Less than -1, so that's a parenthesis on -1 going the less than way. X is greater than 6, so that's, ooh, what's this? Or. It's definitely or. Because this one goes this way, and this one goes this way. Okay? Does that make sense? Do you have any questions about any of these objectives for today? Anything else we need to talk about? Got it?